back to this special session. So now we have a session, we have a first talk on the software engineering for cyber-physical systems, and then 2 talks on education for cyber-physical systems. Should be very interesting. And so our first speaker is very well known to all of you, I hope, Dr. Soumyadip Bandyopadhyay, and it's hard to pronounce your name, I'm sorry. So Soumyadip got a PhD degree in computer science from IIT Kharagpur in 2017. He worked as a junior project assistant in the VLSI Consortium project undertaken by the Advanced VLSI Design Laboratory IIT at Kharagpur from July 2008 to September 2012. And his current research interests include broadly formal methods in software engineering. He has published several research papers in international journals and conferences, and he received a TCS Ph.D. fellowship during his PhD. He was also working as a visiting faculty at BITS Goa Campus from September 2015 to December 2016. And now he is actually assistant professor at BITS Goa. He was also a postdoctoral fellowship from 2017 to 2018 at the Hasso Plattner Institute in the System Analysis and Modeling Group in Germany. And yeah, I think, and he will talk to us about translation, validation of code optimizing transformation involving loop using Petri-net-based models of programs. So Soumyadip, I'll let you go with your talk.
Yeah. Thank you, Dominique. I just share, I'd like to share my screen. So
yeah, this should be in the bottom, the share screen in the middle, the green button.
Yeah, fine.
Yeah.
So my screen is visible?
Yep. Maybe you can make a full screen if you want with your slides.
Fine.
I don't think yet it's full screen, but I don't know this tool that you're using, so I don't know how to make it full screen. But anyway, I think it's visible also this way.
Sir, have you shared your screen or your application?
Application.
Yeah, so that's why it's not coming. If you share your desktop, then it will come.
Okay. Now it is visible?
Yes, sir.
Yeah, it's full screen now.
Okay. Well, thank you, Dominique, for a nice introductions. So here I'm Soumyadip Bandyopadhyay. I'm the assistant professor of BITS Pilani Goa Campus, and my research interest is mainly on the formal methods in software engineering, and where the CPS is one of the part, and I see the CPS as the safety critical systems. So my methods is actually would like to validate the safety critical systems. So in the safety critical systems, there is some level of refactoring takes place both in the model level and the model to code generation takes place. So let's go for a high level overview of the problem. That is, whenever we model any systems of systems using some modeling language, for example, the state flow, or maybe it's ADL model. So the models can refactor using some model transformation rules. And so these state flow models, when is refactored to the another state flow model, so some behavioral semantic preserving translations whether this model transformations is a semantic preserving or not, that is very essential task. And ultimately from the state flow, so that is the intermediate models, one can generate the code also. Now, so this is basically the generation phase. Here is also one can do some sort of verification techniques, so whether the generation phase is correct or not. And then if the code can optimize, so whenever the code is generated, if some compiler optimize some another source level translated programs, so this is called optimizations. So there is also a scope for the verification. So in every cases, so whenever we do some verification approach, we need some formal models. So we have seen in the code level, if it is a control, purely the control oriented programs where the concurrency is one of the important things. For example, the loop swapping, so this sort of things, so the loop invariant transformations. So in that case, the Petrinet is one of the nice modeling paradigm. But if we go to some state flow model, so in that case, we have seen that is the FSMD, that is a finite state machine with the data path, is one of the natural modeling paradigm. So now the question is that in which modeling paradigm we have to choose. So that is basically requirement specific. If we require so validate some, but the data is very important part. So data computation is a very important part. In that case, we will take the Petrinet as a model. And if whenever we will see that is the model is more or less the control oriented structure, so the data computation is not, no one can bother with the data transformation, better to say. In that case, the formal models, the finite state machine is the data path, because the any sort of machines you can make it in some finite state machine form. So you can use the FSMD. Now, so of what kind of things the synthesis phase are going on? One is the model transformations, another is the code generation, and there's a code optimization. So these three phases is the verification of these three phases are very crucial. So the verification of the model transformation is one of the problem statement. Many researchers can work on this particular domain, and obviously the verification of the code transformations. So, and it is widely accepted in the software engineering community, specifically in the compiler domain, in the compiler community. And this terminology is known as the translation validations. So there's that is translation by compiler and the validation by the verifier. So that's why it's called the translation validation. So this is the overall high-level overview of the translation validations. The program are often subject to translated by the optimizing or the parallelizing compiler and go to the target code. So this is called the source-to-source translation. So to prove the correctness of a compiler is very tedious task, and it's basically it's undecidable problem, because we know the program verification is an undecidable problem, and the assertions which is generated is also the undecidable. So how we can do that? So one of the possible solution is that if we make some formal model from the target code and the source programs, a formal model from the source program, and if we fit and we devise some equivalence checking algorithms, and if the equivalence checking algorithm gives the yes answer, that is the two programs are equivalent. Because the one thing I have to be clear, that is the equivalence of the two programs is the undecidable problem, not even partially decidable. But here we can make such a method such that our method is sound but not complete. We are not bothered with the completeness. We just method says that is, it never gives the answer of the false positive. It may give the false negative, but never gives the answer false positive result. So that's why it's a soundness comes from this method. So now the general question is that what type of the code optimizing transformations we are looking into here. There is a several type of the code optimizing transformations reported in several literature. It's a long back, and this sort of code optimizing transformations is usually the HPC, the high performance computing domain. That is the duplicating down, duplicating up, boosting down useful room, etc. And this the in detail level, this type of the code optimizing transformations was reported in the ACM Computing Survey 1990 Bacon et al. So for this optimizing transformation, there are some verification methods. Basically, the verification methods in terms of the programming levels, we categorize in the three parts. Maximum works in the bisimulations based method, because it was first proposed by the Amin Newell in Takas 1998. And that is now more formalized by the George Nikulla, and which was published in the PLDI 2000, and also in one technical report which is published from the MIT, the Ringer et al. Also make one enhancement how the code movement affects the semantic preserving translations. Then it is the modified by the Kundu et al. Published in the CAP 2008, and it's purely the bisimulation based, but it cannot handle if the code can move beyond the basic block level boundary. So this method fails to validate this sort of translations. And using the separation logic, the Bhatia et al. In the Popple 2015 proposed one method. It's basically the bisimulation method, but using the separation based logic. Another method is the inductive inferencing based method, the Matthias et al. It's basically it's a regression. It's a common terminology. It's called a regression verification. So every programs have some common point of interest. That is, whether the states are match and the data expressions are exactly match, and they inferred some inferencing rules in terms of the invariant. So that's why it's called the inductive invariant. And third method is a path-based equivalence checker. The first method is a Carver et al. He validated specifically working on one of the high-level synthesis compiler named Spark. But it's basically if the control structure of the program is altered. For example, the control C and the control C1 and the C2 are not dependent to each other. We can shuffle in any order. So this type of transformation cannot handle, or the code motion across loop. This type of transformation cannot handle by the Karfa at all. But it can handle if the code can move beyond the basic block level boundary, this method can handle. And these all methods are sound but not complete. Then this method is modified by the Banerjee et al. And further modified by this method by using the value propagation based method by the Joshi et al., which is recently published in the TCAT 2019. So our problem statement is one of the important things is that in our problem statement, we would like to enhance our method, that is equivalence check method. But the one thing I forgot that this method cannot handle if the control structure is changed. This fails to validate. So for this purpose, we need to define a formal model, so which can captures this sort of concurrency. So natural concurrency formal model is Petrinet. So our main target is that we have to validate the code motion, loop swapping, thread level, and the code involving the loop across motion. So the code motion, the CTiCPS based equivalence checker can handle. Our previous method tools, the Samatulyata, can also handle. Samatulyata 2 should be handled. So that is our objective. Loop swapping since CDFG based method cannot handle because the control structure is changed. Samatulyata can handle, Samatulyata 2 should be handled. Thread level parallelizing transformations, that is a loop skewing, loop merging, this sort of transformation, CDFG based method cannot handle. CDFG means the underlying structure also the FSMD, because it's a sequential model of computations. Samatulyata, that is a Petri based equivalence checker can work, and it should be work in the extended infrastructure of the tool. It's very obvious. And the loop involving code motion across loop that cannot handle by the CDFG, that can handle the CDFG based equivalence checker, Samatulyata cannot handle, and our new task is to handle this loop involving code motion across loop by the Samatulyata 2. So the overall, the tool informations, you can get it from our group website, that is AOFM, Application Oriented Formal Methods, my group name, and the Samatulyata 2, this tool is already available. And this is basically the workflow from the source program, and this is a transform program, compiler of the manual translator, Petri models. This is the model of S and model of tree. Path constructor, the set of paths is given. Then the equivalence checking strategy is for all paths in the queues is there exists a path in the queue T such that their path level equivalence. That is the condition of execution along the path is equivalent, and that gives the first order, the quantification fee first order predicate calculus, and using the Z3 theorem prover we can evaluate this, as well as the data transformations is also basically the arithmetic expressions. We can also able to find the equivalence, the equality using the Z3 theorem. Yeah. Now, compared to, we have to also shows that is the Samatulyata is the Samatulyata 2 is a far more better in Samatulyata. In what level we have seen, that is in the Samatulyata, the functions are associated with the transitions. In Samatulyata 2, we just change the function is associated with the outgoing. Other things are also. The one thing is that if we do using this manner, in the left figure, if you see after firing of the transition T4, the token values of P11, P13, and the P12 will be the same. And here, suppose after firing of the transition T1, the token value of the J, that is the P2, P3, P4, and P5 will be the different, and that difference occurs due to because of the outgoing edges function. Although here's all identical functions there. And as a brief introduction of the PetriNet, the class of PetriNet we have used over here, it's basically the color PetriNet with restriction one safe. It obeys the determinism, non-determinism cannot handle. No shared variables, and another task is basically it can only work. It's basically the completely specified machines, and all of we know that is the PetriNet is basically a bipartite graph where the two sets of edge vertices are there. One is the place and another is the transitions, and the always interconnection between the place to transitions and the transition to place. There is nothing of no connection between the place to place. So that is the property of the bipartite graph. Now the notion of the equivalence, we check the equivalence between the computations in the computational containment, that is in the one directions, and then the computation equivalence if we prove the other directions also. So let's take an example. So I hope using the examples we can get a better understanding. So in the left hand side, the figure A, there is a one code where the D is incremented unnecessarily in the 5 times. In the transform programs, we assign the d equal to 5 just one time. So in this transformation, this is called the loop invariant involving the code motion across loop. So this transformations is basically affects is reduce the loop over it. So from this translation, from these programs, we have constructed this Petri net. Till now, we have done this program semantics as well as a Petri net semantics. So I have not prove it, but there is a interesting work we can add on, that is we can make some POC theorem proving assistant techniques as these two models, the semantics of these two, one program model, another is a Petri models are very equivalent. So from figure C and the figure we constructed this model which depicts in figure T. Now we can see there is some loop is there. So how many times loop will be executed, we do not know, because we would like to check the symbolic equivalence between two programs. So for that reasons, we have to introduce a cut point from general the program verification technique. So in the figure, in the left hand side figure, which corresponds to the figure A, so here the P1 is the cut point, so input is the cut point. The place containing the package is the cut point. There is a P3 and the P4 are the cut point, and the P5 the output is the cut point. In this one, in this figure, in figure D, you can see that is the place containing the P2 prime is the cut point, P1 prime is the cut point because it's the inputs, and the P5 prime is a cut point. Now we have to define the path. So basically the sequence of transitions from input to output, or you can define it first from the sequence of marking, then the sequence of transitions, then basically sequence of function associated with the outgoing edges. So now we can find, so in this slide we have to show that is the validity of the path-based equivalence checker. That is, from every programs we get a set of paths. Now if we shows that is any computations can be represented using this path, and then we checks only the path level equivalence, our goal is done. We can solve the two programs are equivalent using this method, and it gives a sound result. So in that case, if you see that yeah, so the paths are the dotted boundaries of the path. So one path is basically the alpha 1, sorry, the delta 1 and the delta 8. One path is the delta 2, that is the alpha 2, and alpha 3 is of the form of the delta 3. Similarly, you can here we can get alpha 1, alpha 2, alpha 3, alpha 3, alpha 4, alpha 5, alpha 6, alpha 7. So there's a 7 paths. And here is a beta 1, beta 2, beta 3, only the 3 paths. But so you can see that is some path, some concatenations of the path will be maybe equivalent to the another path. So this sort of path concatenation techniques should also adapt to prove the equivalence. So first half we have to prove that is any computation can be looked upon the increment of this path. So initially let's take a computation for the figure A. So for examples, the computation is a del 1, del 2 and del 3 parallel, then the del 4 and del 5 n times, then the del 6 and the del 7 the m times, then the del 8. So in this computation, so here it's basically the firing sequence of the transitions, the T1 followed by the T2 n times and the T3 m times, and then the T4. When the guard conditions is basically falsified, that is the I greater than 10 will be satisfied, then only the T4 will be fired. So in that case, if you see that is the last member, we represented the computation is a mu p5 and using these forms. And initially the reordered sequence mu p5 bar is empty. Now remove the last member of this sequence, that is the delta 8. and the delta 8 is belongs to the path alpha 1. So alpha 1 is put into the reorder sequence. Then the last member of this sequence is the del 6 and the del 7. Del 6 and the del 7 is the last path of the alpha 6 and the alpha 7. So the alpha 6 and alpha 7 is parallel to the m times, and then we can see this is one, that is the alpha 1 or the alpha 2, sorry, alpha 3, then alpha 4, alpha 5 n times, then the alpha 6, alpha 7 m times, then the alpha 1. And this process terminates when the mu p5 will be empty. So now we will get the set of paths in figure A as well as the figure B. Now the equivalence checking calculus is for all paths in the figure A, there exists a path in the figure B such that their path level equivalence. And the path level equivalence is carried out by the ZT theorem. So here we can see due to the correspondence of the P1 and the P1 prime, so the alpha 2 is equivalent to the beta 2. Similarly, using the concatenation, so due to the shortage of time, I cannot make the details about the concatenation of the path, but we have seen that is the alpha 4 parallel to alpha 6 equivalent to beta 3, and alpha 1 parallel to alpha 3, alpha 5 parallel to alpha 7 is equivalent to beta 1. So the result sections, this is the way we did a small set of experiment and compared to the Samatulyata tools. And we have seen that is the in the Samatulyata, the place transitions are huge, and due to the change in districts, that is transition function is put into the outgoing edges function. So we get a drastic improvements over here in terms of the places and transitions. So future things is just obviously validation of the loop shifting. It cannot handle. This is the limitations. Several optimizing, parallelizing code optimizing transformations using the bisimulation techniques on the Petri net. That is also interesting work. And several loop transformations for the array handling programs, because this work is only the scalar handling programs we can handle. We cannot handle the array handling program. Handling the completeness issues is another goal. So it's a basically very tedious task. So one of the compiler, that is the ComSet, is used this type of the completeness for the particular set of transformations, not for all. Obviously another feature work is missing, that is a model transformation. So I'm not talking about anything about the model transformation. There is also the notion of equivalence is very important during the model transformation. That is also very important. And one of the important things is that if we detect the error in very high level, in very top level, where the maximum error introduction takes place, in that case, our verification process will be more beneficial. So that's all. Thank you. I'm happy to take your questions. Dominique, your mic is mute.
Sorry. Thank you for this very interesting presentation. I will check if we have some questions on Slack. So far, we have no questions. I'm wondering, Soumyadip, so how far are we for having these equivalent checking used by industry, for example?
Can you please repeat your question?
How far are we for having this equivalent checking method to be usable by industry for software development companies or stuff?
Well, actually, you can say that's a very interesting question. So, because see, in the industry, all people generally they doing the model checking. In general, because in the model checking, they only consider about the control-oriented structure. They do not consider about the data path. In the equivalence checking, you should consider the control as well as the data path. So now what the peoples are doing, if the refactoring is there in the model level, in the code level, it is very tedious task. If the model level, some refactoring is there, so in that level, if we do some equivalence checking between two models, that problem will be more scalable rather than to going to the code level. But the code level is also doing very good because there are some automated tools are there. And I know one of the companies is using this sort of tools, that is the Koch theorem prover, which is written in the OCaml language. And if you have heard the Gen Street, one of the company names, is a US-based company. So they are using this Koch-proof assistant techniques, and obviously they are doing some basically the equivalence checking, the semantic preserving translation, the functional programming, but it's basically the functional programming approach. But in the procedural level, it's very difficult to find out. And one possibility is obviously, if it is a safety reactive programs, the notion of equivalence checking is highly relevant and it's an industrial benefit. If we make some really scalable equivalence checker.
Mhm. And so one interesting question indeed is if this can be applied to models instead of code.
Yeah, there is a possibilities to apply this on model. That is obviously, and if it is model is written in the code level, so that code semantics. See, ultimately, whatever we have to do, we have to translate it some semantics to some formal model. So if we validate, if the formalization part is done, then the method will be very scalable.
Good. That's would be very useful too, because you often have some models that describe behavior.
Yeah.
And if you could do some this kind of equivalence checking, would be very interesting.
Yeah.
Okay, very good. Thank you. So I guess we don't have any question on the Slack. I don't see. So we can go to our next speaker.
Thank you, Dominique.
Thank you very much, Soumyadip. Our next speaker here is Ashutosh Bhatia. So he received his bachelor degree in computer science from Barkatullah University in India in 2000. From 2001 to 2005, he worked as a scientist in Defense Research and Development Organization in India. He then received a master degree in computer science from Indian Institute of Science in Bangalore in 2007. And then from 2007 to 2010, he worked as research engineer in Samsung in India. And he was also then the member of the MAC core committee, IEEE 802.15.6, a standardization group. And he also patented a few methods related to MAC protocol, wireless body area networks. And in the end, he received his PhD degree from the Department of Computer Science and Automation in Indian Institute of Science in Bangalore. So looks like you have a lot of good experience. So please, I let you present your talk.
Thank you, Dominic, for giving such a nice introduction. So I'm just going to allow share my screen. Okay, can you see my screen?
Yeah, I can. Maybe you want to make it full screen.
Yeah, it's already full screen in this is PowerPoint presentation.
So I think you will have to share your desktop and not the. I think you're sharing the application.
Yeah, because we see the.
So let me just share the complete desktop. Select window screen, entire screen.
Yes, sir.
Okay, now is it visible?
Yes, sir.
Yeah.
Okay, so good evening, everybody. And basically, when I got the topic that I have to talk something about, you can say, relationship between the cyber physical systems and education. So first of all, this talk is going to be a little bit generic. This here, there is nothing like this is we have worked on, and yeah, there are a couple of products which we will discuss that in computer science department, BITS Pilani Campus, we have done. But in general, this is going to be a kind of you can say opening eye opener that what all is happening related to the education field in CPS. However, there is an interesting point which says that you can also have CPS for education and education for CPS. So I was thinking that which one should I take? The education for CPS, the problem is that many universities in different countries, they don't have any, you can say, any separate, you can say, the course where a CPS has been taught, just taught alone or as a course or a subject. Because the problem is that this is a kind of knowledge which you require is across different domains. So that's why this is one of the difficulty, that how to teach CPS. But we will not actually see that part, but we'll see that how CPS is actually helping to enhance our education system. And we will discuss about that. We all know about industrial revolutions, but we will see that what are the requirement of education 4.0, and how the CPS, different digital technologies and CPS, IoT, AI, ML, VR, AR, all that can help to achieve the goals of the CPA education 4.0. So let's quickly start with this industrial revolution, which we all know. It basically started somewhere in 18th, at the end of 18th century, where people started using mechanization, and that actually using steam and you can say water power, and that actually changed the way the industry was seeing before that, because most of the things people were doing manually. So this mechanization actually helped the industries to do the task in lesser time, and certain tasks which were not even feasible not even feasible manually. Later in, you can say, just after 100 years, we saw the industry 2.0, where 2-3 different energy sources came, and one of them was electrical, and you can say the gas and other. And so they basically enhanced and boosted this industry. And then now the mass scale development, and with you can say coming up with motors and things, we entered into this industry 2.0. Later, and basically when with the you can say inventions of computers and robotics and things like that, now we moved towards the automation, where many processes, manufacturing process, computer and robots started automating, and this actually led to a new revolution. But now we are in the fourth industry 4.0, and some people say that has already begun. Some people say that it is going on in the last 5-10 years. There is no, you can say, consensus between the researchers and industries that when this industry 4.0 started. But the whole idea of industry 4.0 is to involve IoT, involve artificial intelligence, cyber physical systems, okay, to basically to monitor the process, whatever is the manufacturing process and other processes. You can monitor remotely, you can give them command remotely, and that is how, and even you can connect the factory with the shop. And this basically is seen as an industry 4.0, where now mainly the digital technologies are getting integrated with factory. Previously, factories and manufacturing units used to be an isolated place, and that is how the industry 4.0 came into the picture. There is a say that if we teach today the way we were taught yesterday, we aren't preparing the students for today or tomorrow. And actually that is very much true, that if I start teaching whatever I had been taught, means those things are too old, and I probably would be teaching something for industry 2.0 and industry 3.0 requirements, but not industry 4.0 requirements. So this is very important to keep evolving even from the teachers and researchers perspective. The big issue with the education is currently this, that there's a huge knowledge gap between the you can say the student, what he already knows from its theoretical concepts and what he learned in the class. And when he sees that, okay, when he comes out of the class, and then like when he basically completes a degree and all, he sees that the requirement of knowledge is much more, and there is a lot of new technologies that have come which he was not introduced with. And at the same time, although he knows the theory, he doesn't know how to basically handle a problem and do the designs and things and like that. So this is actually a very big issue, that how do we actually reduce the gap between the industry requirement as well as industry requirement and the things which have been taught in the classes. So this is actually just like the industrial evolution. There are also some people have tried to basically put up a education revolution, where the first point 1.0 can be seen as that you just means there's a teacher, and whatever he knows, then you just whatever he remembers, he transfers it to you, and then on a one-to-one basis you just grab it and remember it. That was the concept of knowledge. And in India, we something call it Guru Shishya Parampara. So one person will go. There will be 1 or 5 or 10 students would be there, and there is one teacher who just teaches them whatever he knows. So slowly, when the printing technology came, it actually changed the basically way we used to see the teaching and learning process. And the major advantage was that now you have a better way to memorize and disseminate the knowledge. So it need not have to directly come from the mouth of the teacher. So that actually changed everything. And then we started having classrooms with books and things like that. Then 3.0, basically you can say that, which has started maybe at the beginning of this millennium, where people started using learning from the internet itself. So that was like various MOOCs, various different platforms came where you can just watch video, and they are still keep evolving, that not only you can watch video, you can collaborate with your friends, your teacher, and you can the videos will be interactive and so forth. And the major idea was like accumulation of information was on the highest priority. So you just know everything, okay, because this is what actually this 3.0 solved. However, that is not sufficient, and now we are entering into the world where the students really need a lot of skills related to the innovation, okay, and basically you can say that learner centric. So these are the two very important aspects of 4.0. So it has to be learner centric. That means the learner is at the center. It's not like the teacher, whatever he plans, he's going to feed to the teacher, to the student, whatever he wants. I just tried to make that key, you can say, key take out of education 4.0, that how this is totally going to change the way we learn the traditional methods. Is first is peers and mentors, no teachers. So it's like the job of the teacher basically will be taken by the mentors, and mentors basically guide a student that what can be done, and then they infuse some kind of interest into the student so that they can basically take their own path. Because self-dependency is one of the another key point which education 4.0 says. The second is learning from peers. We all know that the peer-based learning is means you not only learn from your teachers, but you can also learn from your peers. And now, not only the universities and the formal education system is going to be just the source of information or learning. Means some virtual communities can also take the ownership and then start teaching. Okay, and of course, the social media is one of the place from where the teaching and the learning can happen. Another crucial point is alignment with Industry 4.0. See that the teaching has to be changed according to that, so that these students can be absorbed in industry 4.0 scenario, and that requires practical applications instead of only theory. They requires need to generate learning skills, and you have to teach them, means they should learn through the projects, not only the theory courses. And it should be there should be industry aligned courses. So for example, that if you are just understanding like thermodynamics, then wherever the thermodynamics is being used and whatever, that you just take out that part, and then you try to embed the industry requirements and industry processes into the curriculum. The third is anywhere, anytime learning. So this is another thing, that now the learning has come out of the class. Okay, so it need not have to be just inside the class or in a particular time. Okay, and that is very important. You can say this will provide lot of people the opportunity, need not have to look around for that, from where they can learn and all, and that is very important. Another important aspect is personalized learning, and basically it says that the different students or learners have different way of learning, and that is something is called personalized learning. Means if the teacher is giving same content to everybody, and if the different student thinks and absorbs the things differently, that becomes an issue. So you need to generate a learning ecosystem where the school or the college will change according to the student requirement and understanding aspects, instead of the student has to change according to whatever the curriculum they want to enforce. Most important is innovation. Means you just need not have to know things, because in the internet and here and there everything is available. The idea is how can you basically utilize that information and come up with a bigger new concepts and ideas which can solve the bigger problem of society, engineering and technology and whatever. And then finally is the gamification. It has been seen that the gaming, once you gamify the education, that means you teach through the games. Basically, it invokes that ability to take challenges in the students, and also to develop strategies and concepts. So that's why that gamification is a kind of you can say essential key feature of this. I mean, there are so many other things and all. Means in the literature actually is really very confusing. But in this 5-6, I just tried to summarize that how an education 4.0 will look like. 5 I's of learning education: imbibing, that means you should acquire the knowledge inside you. Then iterating, that means you practice it, because until and unless you don't practice it, you will forget even the foundations and fundamentals and the basic concepts. So you really have to do practicing. So certainly we do it, means even in the classroom teaching also we do it. Then the third is basically interpreting. So one should be able to interpret the knowledge what he has acquired, and after iterating, and then he should be able to apply that knowledge into, you can say, the different context with some kind of adaptive changes in this in the existing knowledge whatever he has acquired. And that actually says that yeah, now he is able to interpret that knowledge very well. And fourth is, which is also very important, is like until unless interest is not there, at the end of the day, whatever you have done, imbibing, iterating and interpreting, that will go away. So the knowledge or the area should be, I mean, the student should basically should be able to develop interest in that particular field. And finally is innovating, and that is very important, that until unless you, because see, the lot of manual things which early we were doing manually, now the computers and robots and so many devices are already doing it. So one has to be really innovative to come up with solutions to the problems in a contextual manner. So the bigger issues what the traditional teaching is facing is teachers often still rely on transmissionist method. So that is you just take lectures, and then that leads to a kind of disengagement of the student, and it's like you just listening, and then you don't know how much he is absorbing, and then at the end he has just to pass an exam. So that kind of mode is not suitable for education 4.0. The another issue is context creation. Many times we study theory and but the problem is that we don't know that how to attach a context with this theory and then learn from that context. And in many situations, it becomes very difficult for even for a teacher to introduce context in the traditional teaching methods. And finally, skills needed for 21st century learners are difficult to teach. So for example, they need system thinking, they need critical thinking, they need creativity, they need computer literacy, and they also need abstract reasoning. These are some of the things which are not easy to just teach in a, you can say, in a normal classroom manner. So no more pedagogy means it's not like this is how you teach. Now the word is moving towards heutagogy, paragogy, and cybergogy. So heutagogy basically says that the student should be made self-dependent, okay, and they should come up with their own problems, and then they solve it. They solve those problems on their own. However, a teacher or a mentor can basically provide them problems, or he can you can say support them that see these are the ways that you can do this and all. So the role of the mentor is to make them more, you can say, critical thinking oriented, and so on and so forth. So it's basically heutagogy says that it should be self inspired and self directed learning. Pedagogy we have already discussed, like you learn from your peers, okay, you make teams, you do projects with the team, you learn how to collaborate, and that is what is very much required. That just understanding in isolation and in a classroom is not sufficient. And the final is cybergogy, which basically says that a lot of cyber physical systems you need to incorporate into the learning process, which will provide you a collaborative virtual environment where you can learn. So we know that, okay, no pedagogy, fine, and we got the challenges of it. So it basically says that technology, it maybe is like technology won't replace all teachers, okay, fine, but at least if some teacher is not adopting the technology and it is not using it effectively, certainly those teachers will be removed. So now in order to improve the quality and achieve the goals of education 4.0, the technology should be learned by the teachers as well as and they should incorporate those innovative technologies into their classrooms or outside classrooms. There is a simple model that how the technology basically can integrate with this education, and it is called SEMER model. That basically describes that substitution, augmentation, modification, and redefinition. So what do we mean by substitution is like, let's say previously we were writing on a pad and paper. Now you can write it on your tablet. Although it is more or less same, the only thing is you just have substituted one you can say what you were doing manually, now you are doing digitally. So those kind of you can say technologies which basically you can say which just work as a substitution to the existing mechanism. Second is augmentation, where some functionality is actually improved. So for example, previously you were not able to do something very efficiently, but now with the digital technology you can do. We will see in a minute that how this augmentation, all these definitions map with this real world scenarios. And the third is modification, which basically says that you have modified a particular task, whatever you do in, and whatever you were doing in earlier in whatever manner, now you have significantly redesigned that task with the help of the digital technology. And finally is the redefinition, means there were no tasks like that, but once you introduce the technology, now you can do those things also which were not there. So let's try to just take an example of like class. Let's say in the class that note taking. So if you are using iOS or OneNote to take notes, that's just a substitution. But when your students are choosing their own apps, so that becomes kind of augmentation. Okay. Similarly, when all students are using Notability as an app for all notes, that is actually now you have modified the scenario. And finally, if the teacher can access the student notes, which was not you can say possible earlier, So you have kind of redefined a scenario. So if I take one more, like file sharing, you send the file to the students for reading through the mails, or you, so that is just substitution, or you send the basically share that with the Dropbox or OneDrive folders. That is kind of augmentation. And then you can not only do this from assignment to collaboration, you can also go for the collaboration with the students, okay, on this, like Google Doc, and Shobi is a very good software which basically allows to do collaboration on documents and things like that. And redefinition is iTunes U. So you can see that I just basically listed 5 different class requirements. Okay, like reading is, you can have one PDF email, or you can use dictionary, or you can use annotated documents in iBooks, Notability, or Acrobat Reader. And then you can even have interactive iBooks. So this basically says that how the technology can be integrated with the education and at what level. Okay. But now we will focus more on some of the important technologies which are drastically changing the education system, which we see, and basically they have the potential to achieve 4.0 objectives. The first is virtual reality, and it is nothing but the virtual reality provides the learner to immersed into then contextual environment, and in a 3D environment where he can basically experience, roam around, and see the things. And that actually allows him to like being part of that context. That really helps him to understand various abstract concept and you can say critical thinking. For example, in this figure, if you see this is the MIT research, that what we are trying to do is that a particular worker can operate the robotic arm from his home. So for him it will look like that he is sitting inside the head of the robot, and then from there it will control the robot, and then he can still work directly at the workshop. So this is a kind of, you can say, enhancement you can see out of the virtual reality. There is also one company which works on that called Vital, and see, there is Sogran is that famous quote by Confucius. So you say that, tell me and I will forget, show me and I may remember. And he said actually he said that when I do, I will understand. But they changed it to when I immerse, then I will understand. So it's like you are inside the environment and you are immersed into the context, and then basically you learn faster. So I just tried to summarize that how the VR in education is working. First thing is basically the VR is actually very much the same way that our brain works. Okay. And that says the brain tend to remember 10% of what it reads, 20% of what it hears, and 90% of what it does or simulate. So that actually basically helps any learner to have persistent knowledge instead of just remembering for some time and then forgetting. It actually enables student engagement. It provides active constructive learning, and it enables exercise creativity. So for example, he can really touch the gear and then rotate it and then see what's happening in a virtual environment. And that is basically a very you can say paradigm shift. What it provides actually, it provides an immersive and realistic 3-dimensional environment that involves visual feedback and body movements. So you can even not only see, and whatever you do from your body movements, you can basically change your environment accordingly and all that. So, and the type of applications which are very famous related to this are virtual field of trips. So virtual field trips, for example, it is very difficult for you to now roam around with the dinosaurs. But if you really want, the student want to have a feeling of that they are roaming around near with the dinosaurs, or like they just want to know the history. So what about you can be one of the soldier inside a virtual environment and then try to understand the history. So the whole concept is immersing. So if you just get immersed into that, the learning of the student goes faster. Some of the applications like Titans of Space, a guided tour for planets, immersive app for anatomy. So this Entomu that actually provides you to go inside the body and then roam around, and you can even see all the organs and cells and the blood flowing and things like that. So this is actually the, you can say the sky is the limit for VR in education. Many companies have arrived in this area. However, a lot to go, because developing the content for VR set is there is very less content as of now. So developing a good content for VR in education is really a challenge. Another interesting, you can say, concept is virtual university. So there is a consortium of 12 universities, and they made a university called ECIU. And in that university, they have something called ECIU XR, which is actually a remote university or virtual university. The students can, using their VR headsets, they can see a park environment, and in that environment they can basically collaborate, they can meet, and they can do the projects, and so on and so forth. So this is an, you can say, an interesting idea that in this actually became very useful during this pandemic, when they were not able to go to their colleges. So it's like, if you just hold down and try to think, whatever we initially discussed, correct, anywhere, anytime, and with critical thinking, with context attachment, these are the technologies which basically provides you can achieve the goals of this thing. Another interesting technology is augmented reality. Here you are basically kind of putting up virtual objects in the real scenarios, and that actually in that way it is a little bit different from the virtual reality. So for example, in this figure you can see that there is a table, and the person wants to know how this sofa will look here. So this sofa, the sofa is actually a virtual object, rest of the things are real objects. And then this kind of technology is useful for many different, you can say, verticals like interior design and this and that, and medical and this and that. However, one interesting point is that you can not only augment the reality by putting up visuals, but you can only also augment the reality by putting up auditory information, by putting up haptic. Haptic means is like anything which is related to the touch. So even you can have the touch kind of experience by augmenting the reality. And then the final one is somatosensory, where you can feel pressure, you can feel temperature, or any kind of other sensations. If, let's say, if a person takes his tablet and enters into a very cold environment, real cold environment, then there he can really feel that much of you can say coldness or that temperature. So however, this is not that much easy, but theoretically anything can be embedded or augmented either visually or in this manner. Actually in education, there are mainly two types of directions people have taken. One is AR experimentation, and second is supplementing current pedagogical materials. So for example, if you can see in this diagram or figure that if in a book there is a solar system, so you just make your tablet in front of the solar system, so you will certainly get a 3D model of that solar system, which is also interactive. So you can interact with that 3D model. That basically certainly enhances this thing. Another thing is AR experimentation, and we know that, see, the real you want to need the real life experience. Like, say, if you want to do the science project or science lab, you need, or electrical lab, you really need a lot of equipments and all. So, and at the same time, everybody in this world is not having those facilities. So this is a kind of like, you can have virtual labs in this domain, where you can, anywhere in the garden or anywhere, you can just put up your you can say the gadgets and the instruments and equipments, and then you start experimenting with that. So this is actually a very cost-effective solution, and in line with the anytime, anywhere scenario. Okay, so we will basically see in our department, one of our students, they are in 4th year, they have developed, they have started a startup called Elixir Systems, and now they have developed a kind of augmented reality, you can say, for NCERT books, that the books basically which basically go for 7 to 8th standard to 12th standard, and they just experimented this particular their app. And the app what they have designed, that as of now they have won most of the prestigious award, and they've even outside, and they have a very good collaboration with NCERT. The NCERT has given them to basically to make the content, AR content for this thing. So I will just, with your permission, I will just try to show you that you won't listen the voice. Okay. So you see this, how this augmented reality is working in. So I hope that you got the point. That idea is basically you just direct your mobile camera towards a particular book, and then whatever circuits and things are there, you can get as a 3D model, and you can even change its behavior and say, perform you can say some kind of functionalities there. So that is what our students have done. They have opened this, they've just started this company. The another idea is basically the Kalam Labs, which is basically a lab for using augmented reality, and we just show you here how this Kalam Labs works. So anybody can, anytime, you can say,
in the present education scenario. What if you could pick up your smartphone or tablet and bring home the school's science laboratory right in front of you? Kalam Lab provides a student all the 60 plus science experiments according to the 12th board examination. Each and every experiment has got 2 modes. Tutorial mode, that shall be, they can basically ready to be expected.
The second optical read, so as to match.
In this fully guided tutorial mode, each and every...
Yeah, so I won't go through with this complete video. The idea was just to show you that how on just a garden, all the apparatus and equipments can be selected, and the person can perform the labs, whatever it has been defined inside. So another concept of, you can say, how much time I have?
You're a bit over time now, so you should try to finish.
Okay. So just I just try to finish it very quickly. Yeah. Okay. So yeah, one concept is teaching factory. The idea of teaching factory has come from nothing but from the medical science, where the colleges and the hospitals work in tandem. Okay, so the idea of teaching factory is actually, why not the whatever you are learning inside the classroom that has come from the real factory, and then you contribute towards that factory. So this is basically the idea of teaching factory. However, there is some kind of CPS integration also with this teaching factory. So for example, that we call teaching factory, that they call teaching factory 0. And the idea is to here integrate all cyber physical system technologies like NFC, AR, VR, robotics, and different analytics process. So here, if you can see that students can design the product using CAD, and also that they can store that data into a centralized database. Then once their design is done, they can basically use virtual reality to validate that design, that whether AR and VR, to validate that design. And at this stage, there will be experts also from the companies, which basically help them to see initially your design has some issues or validation. They can also validate, because you are putting up all the data while you are working. So it's like you're getting the expertise of the real engineers who are really working on in the industry. And once you have simulated and designed everything, then you go for real drilling, milling, and turning labs. And here comes the you can say the CPS for industry 4.0, because all these drilling equipments are nowadays, according to CPS, are going to be connected with Wi-Fi and various communication technologies. You can even gather all the information in your mobile, and then you can see how the process is going on, and whether you can even evaluate your work with others, and that really gives you that in reality, when you will go there, how it will work. So it's like the total integration of you can say many CPS systems, then how you can reduce this gap between the academics and the industry by doing exactly the same projects which the projects and technologies which the real industry is working on. So it's basically the last I just want to focus about the AI for special education. So you can see that there are some students who have kind of autism, and that says that they feel shy when they kind of interact with other people and all, and sometimes they don't want to have eye to eye contact. But there are companies which are kind of replacing this human based, and that they are replacing that with the robots, which will help them to help the student to you can say develop their interpersonal skills. So this is a very, you can say, a very useful concept, and many schools in Europe are using this concept to especially work for that people, the students who have special needs. Okay, maybe I will. This is just the last one. I will not explain it, but the idea here is that the only education is not important. Your physical and mental length is equally important. So you wear a lot of biological sensors which will actually monitor your health status, the lifestyle, the sedimentary lifestyle or what. And then if you have not done any movement since 4 or 5 hours, then it will ask you to that, okay, go and do the movements and so on and so forth. So this is another kind of integration is required in 4.0 using the biosensors. Yeah, thank you very much. I just a little bit rushed up at the end. I hope that this was nothing like we did, but we did only 1 or 2 projects. But this is just a This was just a compilation of various works happening all over world, which says that there is a lot of scope in education for CPS, AI, AR, and other digital technologies. Thank you.
Thank you very much. But that was very good introduction to that topic indeed. And I think we have many questions on the Slack, if I remember well. Okay, let's check. Do we have time for questions? I guess so. Or do we take the time?
Yeah.
We have one question. Okay. Sir, can we say that the new education policy is a good step towards the 4.0 model of education?
Certainly, yes. The new education policy which has come in India actually is trying to target all those points which is basically related to education 4.0. So they have done a very you can say rigorous study, and then come to the conclusion that this is how the education should be.
Okay. Another question here we have, this is not a question, but a comment. Straitjacketing an ancient learning system into education 1.0 is unfair. There was a significant original research in ancient India in various fields. Dharmapal explains in his book, The Beautiful Tree, these terminologies are post-industrial revolution and should be applied to those contexts only. Any comment on this?
Yeah, means say the thing is that we cannot really eliminate, means whatever I have understood from the question, we cannot really eliminate the importance of a person, whether he is whether you call him a teacher. But the only problem here what we are facing is like, then it cannot be for all. So there are a lot of scalability issues, and the word, if you remember the slide what I talked about, is like there is a boy who sees that there's much to do. So there are a lot of abstract notions and all which are really difficult to teach. So yes, there's no way, we are not trying to say that the 1.0 what we talked about that was wrong, but it has certain limitations which can be overcome by all these digital technologies. For example, if there is a a special person, student who has autism problem, then one-to-one basically somebody can teach him with very passionate teaching, but then you will not be having that many resources. So yeah, means it's like both ways. Only the technology is not sufficient, but you have to take help of the technology to make the future of the students better.
Okay, thank you. We have again 2 more questions. So what is the difference between education and training?
Okay, so actually nowadays this kind of notion is getting blurred. But technically, if we say that education is you are trying to understand the technical knowledge and fundamentals, but training is basically now you have to do a precise work as a worker. You go to you go in a company, and this is the precise work. You have to learn end to end that how that work has to be done. And it could be possible that your whatever education you have taken for that work, that will help you to do to basically do the training, because it may be possible that if you have not taken education for that, you cannot take the training, because you have to understand that inside of what is happening here. So education is like a broader perspective, training has a narrower this thing. But this also we see as a part of teaching factory and all, that now the project based education is is a kind of training the person to or making a person for future jobs. Okay, so that he will be good in at least in the concepts and the state of the art technology and the design, and so that. However, at the end, training will be there. Whenever he will reach there, the training has to be done. So this is like I see that as a difference. Uh, do you think AR and VR can be combined to introduce a new means? Yes, I did not include the those slides either because of the time constraint, but yes, both together are doing wonders. Okay, this is, you are very much right. So both together, if you just augment the reality at the same time you use VR. However, there is one issue with the VR is that the handsets are costly. Okay, but with AR you can just use your mobile. And the second, you can say the challenge with the VR is when you wear VR headset, very quickly after 7 or 10 minutes you get exhausted. So so for that, the Google Glass and the Apple is also coming up in 2 years a new glass which is going to be a revolutionary change, where you can see in augmented reality in front of your glass whatever in reality is there. On top of that, all other information will be displayed into the glass and objects and things like that. So that is going to be a new revolution in this field.
Okay, well, thank you very much. So I think we will stop now, and we have no more questions on the Slack, but thank you for a very good presentation.
Thank you, sir.
And then we have one last presentation in this track, again about education for CPS. So we have Swaroop Joshi. I didn't see a title of your presentation on the website though, but I will still introduce you. So Dr. Swaroop Joshi is an assistant professor in the School of Computing at the University of Utah. He earned his bachelor in computer engineering from NTK University, Master of Technology in Computer Science and Engineering from IIT Bombay, and PhD in Computer Science and Engineering from the Ohio State University. So his interests are is in a range of topics on education, technology, and software engineering, including but not limited to computer-supported collaborative learning, active learning, game-based learning, project-based learning, programming languages, compiler designs, mobile app development. He's actually involved in engineering and computing education research and has presented papers in some leading conferences in these fields. He currently serves as an associate editor for the Journal of Engineering Education Transformation. All right, thank you. So I will let you share your screen.
Thank you so much, Dominic. Oops, wrong button. Okay. Yeah. So I hope everyone can see my screen.
Yeah.
And yeah, great, thanks. And it's actually nice to follow Ashutosh because he covered a lot of background that I was afraid I'll have to skip because of time. So that's good. Similar to his talk, I'm talking about the intersection of cyber physical systems with education, but with my interest in computing education, I'm going to focus on that. Also, this is the last talk of the day. It's already late in India, so I'll try to keep it short. Essentially, I plan to briefly talk about computing education and computing education research, and then present 3 projects that use CPS in computing education at different levels in different backgrounds. Okay, so once again, similar to Ashutosh, this is not a work that I have done. Consider this more like a literature review of current trends. All right, so I'll skip over this part about what is CPS and those things. I think you all heard about it all day long. But one quick thing, so this is a picture from United States National Science Foundation, NSF's workshop on a CPS program. So they have been funding CPS related research for almost 14 years now. And we can see its effect in US education and research in general. So the CPS core is this, which has several things we talked about. There is IoT, there is data analytics, there is design, there is verification, and there is also this human in the loop, which I think is also important. And then this picture says you have several application sectors like manufacture, agriculture, medical, etc., etc., etc. I'm sorry. Okay. I'll just talk about this little quote here from the same document. This is CPS technologies are transforming the way people interact with engineered systems, just as the internet has transformed the way people interacted with information. For example, this talk would not be possible in the format it is if we did not have internet, right? Both in terms of delivery as well as preparation. I prepared everything entirely online. Maybe 30 years back, I would have to go sit in the library and make notes and then create overhead presentation. So just like that has changed, CPS is and will change a lot of interaction with the actual physical systems in coming days or years. Okay. Quickly about what is computing education research. I mean, it should be straightforward for most, or that's what we think, but let me specify a few things here. So computing education research is about understanding how people develop robust models of notional machines. And what is a notional machine? Notional machine is an abstraction of the computer that one can use for thinking about what a computer can and will do. So when students have a mental model, a notion about this is how the computer is working, this is what happens when I write a code, and when it takes the true branch in the if statement or goes back looping. So that is the notion of how computer works. And then an educator's job and a researcher's job is to help the students to achieve those correct mental models. Okay, computer education has focused on coding largely, but it can and should go beyond that, says another prominent researcher in the field. So this is broadly the area, I mean, a very broad area that I like to work in. It covers everything from first year education to learning about designing softwares in the core computer science 4-year bachelor program, as well as outside it. And the examples we'll see are actually from outside those 4 years. Okay. So yeah, why CPS in education? I think Ashutosh largely covered this, so I'll quickly go over this. Learning things with new technology is what we started getting with ICT, that is information and communication technologies. So online learning, having MOOCs like Coursera, for example, which is commercial, or NPTEL that is prominent in India, led by several IITs, etc. The Khan Academy and other such famous things. So they happened already, but then beyond that is CPS, where we get some cyber and physical systems. So related to that is learning in a new way, and this realization that different students have different backgrounds, different skills, different strengths, and different weaknesses, and they each of them can learn in a different way with different opportunities, different resources, different affordances is capturable with CPS. And finally, there is learning of new things. So future jobs will use technology or just domains that are not even invented yet. For example, 20 years back, mobile app developer was not a thing. Today, many people want to do that, and they do that very successfully, right? So these things will keep happening. It will keep pushing us towards newer things. All right, going forward. So why or how CPS in computing education, coming to my specific domain. So the broad ideas are coming from Hahn and Burns 2019, which is a chapter in a Cambridge Handbook on Computing Education Research, which is a good comprehensive volume on several things on computing education and research. And then there are some specific examples that we'll look into. So young children and certain demographics, for example, particularly in the West, there is this stereotype of computing education being a nerd's thing. You need to have a lot of math background. You need to have a particular kind of mentality to get into that. So many demographics kind of stay away from computing education. So some statistics in US, these are a few years old, but about 57% of all undergrad graduates, bachelor graduates, are women, if you look across the board, but less than 20% in computing are women. So there are these type of discrepancies, for example. Related to both these young children as well as some certain other demographics is conventional programming is mostly text-based. You have to use those very dark background and plain text editors to write programs. That is again a sort of a stereotype, but not very far from truth, I would say. Requires other skills, as I said, and not cool. It's a nerdy thing. These are all stereotypes. And then perhaps more applicable to the young children factor is this concern about screen time, which we are observing a lot during this pandemic particularly, right? So because of several such reasons, the traditional computing education is not prominent with these particular groups. So few researchers have tried to address, okay, I'll pause it for a second, tried to address that with creating physical systems that are tangible systems that have robotics, but not simply to play with a robot, but to actually program a robot. Okay, we'll go and take a look at this video. This work was started in Tufts University, and now it has commercialized, so you can buy these products actually online outside. Okay, all right. So here is the Kibo video for 2.5 minutes.
Meet Kibo, the screen-free STEAM robot kit for young learners. Kibo is a screen-free programmable robot kit that introduces coding and sequencing to children ages 4 to 7. Based on 20 years of research, Kibo lets kids build and construct, code, and decorate their own robot. Kibo introduces coding by giving students a way to program their robot with wooden programming blocks. They arrange the blocks in a sequence, scan their sequence with Kibo's built-in barcode scanner, press the Go button, and the robot comes alive. Dr. Marina Burrs, co-founder and chief scientist for Kinder Lab Robotics, describes the importance of introducing coding and robotics to young learners.
We think of coding as a literacy, and that means you want to understand how the world works. just like reading and writing. Think of that for a second. So reading and writing is not just so you can become a professional journalist or a novelist. Some of us will, but most of us will not. The same is true for coding. Some of us will become software engineers or programmers, but most of us will not. And we want to learn how to code anyway, so you can manipulate and understand what's going on around us, so we can really think in abstract, problem-solving, creative ways.
Using the art platforms, Kibo can become anything a child can imagine. It can become a bowling ball, a car, a migrating gray whale, a very hungry caterpillar, a cultural dancer, an artist, a cave explorer, even a build and brick masterpiece. And Kibo offers over 160 hours of curriculum aligned to current computer science standards. Imagine the possibilities. With Kibo, children get hands-on experience with the engineering design process by exploring sequencing, programming, cause and effect, troubleshooting, problem solving, and collaboration. Bring your lessons and activities to life in an engaging, interactive, and fun way with Kibo. Join the thousands of students enjoying their STEAM learning through creative play. For more information about Kindle Lab Robotics and Kibo, go to Kindle.
Yeah, and you can find that information. So let's skip that part. Okay, so that's one example of using a tangible or CPS system to teach kids as young as kindergartners coding. And some quick results and quick look at some of the results from actual research. So one of the 2016 paper, they studied 60 students in the kindergarten to second grade category. They had an 8-week robotics curriculum. And one of the most important findings was preschoolers were able to create programs. And some of them, not just sequential programs like, go straight, go right, and things like that, but also programs involving conditionals. So if you find this, then turn this way or something like that. And even loops, so which are fairly advanced techniques given their age. Another paper from 2012 with 54 kindergartners showed it improved the kids' sequencing skills. So, putting things from the smallest object to the largest object, or arranging them with a certain color or something like that. And sequencing skills are predictors of numeracy and literacy in future. So these skills help not only with programming itself, but with other important life skills as well. Then a third study, this is a pilot project they did in Panama. So, collaborating internationally, where they work with students on the autism spectrum. And the N is small because it was a pilot study, 12 students in the age of 4 to 7. And the research question they asked was, are children with ASD engaged with the Kibo robot? You perhaps know autism spectrum students have issues with focusing, issues with concentration, etc. And related to that was, are they asking questions? Are they sharing their work, etc., etc.? And there was a positive response on all of that. So similar to one of the examples that Ashutosh showed, CPS helps with autism spectrum and other special need categories as well. Okay, going further. So there is this important notion of who are going to use software now or in near future. So a study by Amy Ko and her colleagues in 2011, it was actually a paper called by ACM, a survey by ACM. And what they found is most programs written today are not by professional software developers, but they are by non-professional end users. Examples could be a teacher who is using an Excel spreadsheet to maintain her student grades, and then to compute the final score, the final grade of the semester or the year, she has to program. She has to write a program. A little bit of programming of the Excel cells to find out who is getting A, who is getting B, etc. Right? So there are several such small programming opportunities that many non-professionals are and will be using. Another example is where we have smart homes. So you have to program, say, a thermostat where it should say, okay, on weekends the AC should run till 8 o'clock, whereas on weekdays it should stop at 7 o'clock. Because we get up early and go out. So things like that. And then there are interesting points about, if it's a family of 4, what does hot and cold mean? When should the AC stop and things like that? So there could be complex programs that you have to write even at home as these things get complicated and enter our life. There are also instances of musicians and DJs writing live codes to create their product. And there is this aspect of informal learning. So exhibits in museums, or going to special exhibitions, special presentations, where you could learn through AR, VR, as well as certain other interactions. So the next example we'll see is research at Georgia Tech, and it's part of their larger project where they're teaching programming using music. But this tune table, which is an interactive white table, was used in a museum in Atlanta, Georgia, Museum of Design Atlanta, MODA, and they interacted with 2 groups of school field trip students and saw how they learn or understand programming using these music bits. So let's take a look at that video quickly, and this is less than a minute. Okay. So this study and some other studies that have used music or other, quote unquote soft skills to introduce programming have found more acceptance from more diverse population. So women in particular. And another thing is, the question is why tangibility? Why could it not be a tablet, right? We could give them an iPad and work on it. So some people have done research comparing these 2 aspects as well, a tangible physical system that people can touch versus a software app. And the observation was, although people could create similar programs in both, people were more engaged when they worked with tangible and physical systems. Also, they interacted more. So for example, a family goes to the museum. If you give a tablet, it's going to be maybe only the son in the family who will play around and create the music. Whereas when it was a system like this, a physical system like this, the entire family, mom and dad and brother and sister, all of them could move pieces around, try other things, and they interacted more and contributed to the code learning process together. So there are these advantages of CPS in this sort of computing education. Okay, and the final example is again for a special education. So music programming blocks for visually impaired children, something that would have significant restriction if we only think about software or only an app on an iPad or something like that. So this is an even more recent study, again, fairly preliminary at this point. This is from Turkey. Their N is 14, 7 boys, 7 girls, average age is 12 and a half, and they have a range of visual impairments. They have created specially designed blocks with grooves, so they can touch and feel and figure out what this block is. They have also deliberately stayed away from using Braille for these blocks, because at that age, learning Braille itself is a cognitive load, and this is going to be different. This is just for the music and computing through music. So the visually impaired children can touch the blocks, and each block has some meaning. It's an encoded block, and then place those blocks on a rack, which is again a specially designed board which has grids basically, so you can fit the block in it. And then with the help of a mentor, scan the blocks through the NFC, near field communication. And there is one of the blocks is play. So once you go to the play block, it starts playing the music. So we'll quickly look at that video as well. Not too long, but I really like this video. It's less than 2 minutes. Let's take a quick look. Awesome. Great. So that was the third third product I wanted to show. Interesting things, after this workshop, when they did focused interviews, some things that came up was this was first time for many of the students to be introduced to any sort of programming, and they got a new interest, of course, and started asking about what next, what more can we do with this, what other programming languages can we learn. So by the way, there is a lot of CS technical stuff that is also involved here. So there are languages to be designed for converting the codes on the blocks, for example, to an actual system, because of course, at the back end, it's going to be a real, some real code that is going to be run, that is to be executed. So there is another level of translation, compilation, syntax, and everything that is to be developed. So very interesting features from a pure computer science researcher's point of view as well. Okay, so these are some examples. Quickly, limitations. The biggest limitation is cost. Production maintenance upgrade is very expensive compared to writing a software. Right? You don't really have to create physical things. You need a reasonably professional manufacturer to get things out there, which is not necessarily true with software that you can write with, again, reasonable experience. Again, the second point, somewhat related, but saving and then restoring or copy pasting program bits is going to be difficult. You can't simply get a block of or a set of 10 blocks and copy paste it to create 20 and then 30 blocks and share it with friends that way, right? Also, a comparison is perhaps with a chessboard physical. I am playing with my friend. We stop at we pause at a midpoint in the game and then want to resume tomorrow. So we have to make sure the board is physically not disturbed, right? If we are playing through computer, then we are not really worried about it. If the physical board is disturbed, it's going to be difficult to recreate the game, whereas the software board could recreate it easily, possibly, right? And the third limitation is the perception that real coding, what the real software engineers do, is in text-based languages. And again, largely true, but hopefully with upcoming research and change in the spectrum, including the Education 4 that we heard about, things will change here. But I'll end on a positive note. Advances in manufacturing technology, especially 3D printing, becoming easier and cheaper, and with the benefits of CPS in education on the several other aspects that we saw, will perhaps help us overcome these limitations. Okay? So that's largely what I have. I'll skip through the reference slides, but they'll be available. You can go to my website and I'll upload it there. So thank you. And if you have any questions, let me know. If you'd like to possibly collaborate and work on these, let me know. With some faculty and students at BITS Goa, we are running a weekly computer education research reading group, and we are happy to collaborate and explore several dimensions of that. Thank you.
Thank you very much. Excellent presentation. And so we have, I think, one question or two questions on the Slack. In your turntable demo video, can you give us one or two examples of the sort of computational elements in the context of music programming that are present?
Yeah, okay, so Pritam has said it's kind of answered by subsequent video. But yeah, I mean, briefly, no problem. So yeah, computational elements, as in, people have to actually program and, well, I'm a little lost right now. But yeah, so computational aspects of, actually getting the encoding on the tangible things to something in the real computer at the back end. I think that's what I talked about, and that's my answer right now. I don't know, Pritam, if that answers your question.
Okay, so I found that quite interesting to see this programming blocks for robots, and I'm wondering how does it compare to the Lego robots with this this specific language, or several robots companies have developed simplified tools and also we can even say simplified languages for visual programming language, for example, to program robots.
Right. So yeah, thanks for bringing up Lego. I mean, it kind of started there. It is the first tangible sort of gamified programming language that people talk about in literature. And I did not, I did not really mention it because of a short time. But yes, you should give credit to Peppert and people who created that work. So it's largely in the similar domain, I would say, other visual languages or other simpler ways of programming robots. Also the visual languages like Scratch and so on, they're all geared towards solving the same problem. But I think CPS and these tangible products give an additional edge, especially for the different demographics that we saw in those 3 videos. People having visual impairments, people having autism issues, and very young children. So the CPS kind of adds to affordances, or making it available, approachable, enjoyable to these audiences as well. Yeah,
it's also interesting because we work on language engineering for CPS development, and in one of our work we highly consider usability of languages. So even underneath the tool there is a language that the people modeling language that people manipulates. And typically for modeling language, you usually think about mostly 2 kinds of concrete syntax. Syntax being the syntax that the users manipulate. So you have code as coding languages, but you also have a graphical syntax like diagrams and things like that. And now this can be seen as a physical syntax for a language, like with these blocks. It's kind of a third kind of syntax, and it's quite an interesting idea.
Right. Yeah. And there is another aspect to these physical or tangible languages, I think. So most programming languages that we use are English based, and there is a lot of population in the world which are not English based. And music, for example, is a universal language. Then you can identify the tune. You can make difference in what happens when I put this block versus that block. So you don't really need an English-based, text-based language for expressing what you want, or even learning the basics of programming or algorithmic design. When I specify the steps, it's then deterministically going to do the same thing again and again. I think that's an important aspect of the 21st century learning that we heard in the previous talk.
Mm-hmm. Yeah, thank you. Very interesting. So that ends the session, I guess. Soumyadip, do you have anything special to say, or Rakshit?
No, sir, I think that should be it.
Yeah, so I think this is the end of our today's session. So we'll meet tomorrow at 10 o'clock in Indian time. In CET time,
6:30. 6:30 a.m.
Tomorrow at 6:30 a.m. I didn't check. Really?
Yeah.
All right. On a Sunday.
actually on the point.
What can we do? This is a problem with time shifts. Okay, good.
But in the next day, in the session one, we have plenty of talks are there. Now, one is the two talks from the ML for CPS track, and one talk from the startup for CPS. And there's a one interesting panel discussions, because the BITS Pilani basically deals with it's a main product is undergrad. So the undergrads research how we can improve it. So using this manner, we will make a panel discussions from 12:30 to 1 p.m. in the IST. So then there is the session 2, session 3, and the session 4. The 3 sessions are there. In each session, there is some track talk is there. One is basically, I think 2 or 3 from the MPM for CPS, 2 from SE for CPS. And after that, there is a huge panel discussion. So panel discussion topic is already posted in our website. So please look into it. And panel discussion will be very exciting.
Yeah, should be very interesting.
A very nice event, first day. And thanks to our kids especially, and also the Dominique and all the speakers, Swaroop, Ashutosh, and Hans, and other speakers also.
So thanks to the participants as well for keeping it lively, asking questions.
Obviously.
Yeah.
Thanks to the all participants.
Okay.
Okay.
Thank you all, and see you tomorrow then.
Yeah.
Thank you. Good night. Bye-bye.
Bye-bye.
Thank you. Good night.
Good night.